In mathematics, right, we generally look at a whole heap of different things. One of those things is kind of solving problems. Another one that you might have seen is finding and looking at patterns. Okay, and in a formal way, we can imagine a sequence of numbers as a kind of mathematical pattern. And what I want to show you today is that there's kind of more to meet the eye to these kinds of patterns. For example, if I look at this one over here, I can see there are these kind of squares I'm creating.
Times tables.
So here I've got one dot.
1 times 1.
How many dots do I have here?
4.
16. 16. And as Callum very well pointed out, these are actually the square numbers that we have.
He actually did put that.
No, that was me.
2 times 2.
Yeah, say 2 times 3 times 3.
3 times 3.
I heard you say 1 times 2.
4 times 4. So you can see year 11 that we don't only have a visual representation.
No, mathematical.
Yeah, right. What would the next one in the sequence be?
5 times 5, 25.
5 squared.
Same idea, right? But let me show you something else. Let me show you something else that's happening. Now, this is a sequence, right? These are some numbers that follow a pattern. They're just taking whatever position you're in. This is the first one, 1 squared. The second one, 2nd squared. The next one, 3rd squared. 3rd squared. 3 squared. And so on and so forth. But let me show you something else that's happening. Let's think about something that's different. It's something called a series. So a series is different to a sequence because for a series, we're doing something else. We're summing the values. We're summing the values. So for example, right? If I start with 1, that's actually 1 by itself.
Yeah.
But what's the next odd number after 1?
3.
3. So why don't I say, what's 1 plus 3? Well, that's 4. Okay. Well, what would be next? If I keep going with the odd numbers. 1 plus 3 plus 5, what's that? 5 plus 3 is 8. 8 plus 1 is 9.
That's hard.
What's the next odd number after?
7.
7?
We do this for
Yeah? Oh, sorry, no. Plus 9. Plus 7. Jump the gun. What would that give me? What's that? 4. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7, 16. So you can see year 11 that this pattern that we see, it's not restricted to just a visual thing or a mathematical thing. There's like another layer happening beneath that. There's another layer happening beneath it. Let me give you one more example of a mathematical pattern that's very common. Has anybody seen this pattern before? Sorry. Cool. Okay, so the Fibonacci sequence is another interesting mathematical sequence in that you start with 0 and 1 and you add the 2 previous terms and you get your next term, right? So for example, I'll go from 0 and 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. So on and so forth. Alright, why this sequence is interesting is because this plant here, it's got a funny name. I can't remember. It's called like a squeeze weed or something. I can't remember. What does it say? Sneezeboard. Yeah, that's right. Yeah, sneezeboard. And if you come over here, they've done a little graphical representation of it. Okay, so this is like a side-on view. And I want you to pay attention to these numbers. And I want you to see, look at the branches that happen on this little sneeze board.
One more branch.
Okay, so let's go through the layers. Here we've got 1 branch. Here we've got 2 branches. How many branches do we have here?
3.
3. What about the next layer?
4.
1, 2, 3, 4, 5. All right.
So it goes up.
Let's keep going. Yeah, let's keep going. Where would I draw the next one? 1, 2, 3. Yeah. So I'm not trying to force this, but I'm trying to show that these intervals are pretty regular, right? The next one here was 1, 2, 3, 4, 5, 6, 7, 8, and we could keep going. But where do these numbers? Where do you see these numbers? Right, the Fibonacci sequence. So not only is this pattern something that they've thought of, they see this pattern. It's actually exhibited in the nature that you see around you. I'll give you one more cool example.
Plant everywhere, right?
Very common. Can I give you one more example? Is that alright? I want to show you 2 more things. I know I'm going along about this, but I just think it's really cool. Alright, we will. We should. I want you to take one number in the Fibonacci sequence and divide it by the number before it. Okay. So over here, take 8 and divide by 5. Can you do that in your calculator?
Yeah, got it.
What did you get?
1.618.
1.8. So, in the Fibonacci sequence, another property is that if you take one number and divide it by the previous term, the one before it, you always get a very similar number. I've got the whole Fibonacci sequence here. Choose any of these numbers. Everyone here, choose 2 terms and divide it by the one before. What did you get? Which one did you choose?
I did the 144.
Yeah.
I got 1.61.
Okay, can someone do one of the bigger ones?
I
Someone
did
do.
the 17711 and the 10946 down the bottom.
Oh yeah, yeah. And what did you
I
get?
got 1.61.
1.61.
Right,
so this number.
This
number.
This fountain an error in it.
Where?
Go back
2 divided by 1.
Oh, okay. So
Yeah, you get
good.
two.
Yeah. So you just get 2. So this is an approximation. The larger you go on, the more this pattern is exhibited. Okay. So the further we go down this pattern, the more it's exhibited.
Yeah, I noticed that.
What I want to show you is that this Fibonacci thing, this number is exhibited in selling stock prices, right? So, see this number up here? Where have we seen this number before?
1.618, no way!
Yeah, right. So there's something called a Fibonacci extension when you do trading, because the whole idea between trading is you want to buy low and sell high. Right. So how high do we want to go? Well, they have this thing called a Fibonacci extension, which predicts how high a price of a stock can go. Okay, and I'm not too sure why it comes up, but it's a number that seems to exhibit itself in nature and also in human behavior.